Welcome back. It's April 26th. That's the day after I started doing some videos on air masses, and I want to talk about fronts. So air masses continuing and fronts. The first front is a warm front. A warm front leading an area or a warm air mass into a region. Warm fronts are always designated on a weather map with half circles colored red, and the half circles pointing in the direction the front is leading the warm air mass. So that is your first type of front. Your second type of front is a cold front. That's always designated with triangles, and your triangles in blue, always in blue, I didn't say that I don't think, are pointing in the direction the front is moving. In this case, up the paper, and behind that front is a cold air mass. Based on what we were talking about yesterday, that might be continental polar air. Just like behind the air mass here, the front here, the warm front, we would have a maritime tropical air mass. So, that's our basic beginning. Fronts, two of which are here. Your warm front in red, half circles pointing in the direction the front is going, and your cold front, triangles always in blue pointing in the direction the front is going. And again, in the warm front's case, leading in maritime tropical air into the region, and the cold front leading, typically for us in the United States, continental polar. We have two more types of fronts, and so we'll color in here fronts continued. And we have to continue our discussion. And the two types of fronts that we're going to deal with now are stationary fronts, which you might be able to tell from the name would indicate that they're not moving very much. And finally, an occluded front, which is the offspring of the meeting of a cold and a warm front, as it were, poetically speaking. So first, a stationary front. The stationary front has both a cold front and a warm front involved. In this case, a warm front is running into a cold front, and neither of the fronts is able to move in the direction they were headed. They become stationary. And stationary fronts occur frequently across the United States, and they are often precursors to more severe weather that develops over several days. One of the characteristics of a stationary front is that there will be warm air moving parallel to that front. Oh, I put that arrow on the wrong side. It should be the cold air behind, sorry. So the cold air should be behind, right? We'll make this deeper blue so that we don't get confused. So there's cold air sweeping behind the cold front. Remember, the cold front is moving down here. That's why you have to have that blue arrow of air sweeping behind it, parallel on that side. And of course, we then have a sweeping zone of warm air coming behind the warm front. And these two bands of parallel moving air lead to a particular type of storm if a certain condition happens along this stationary front. So again, this type of front is called a stationary front. Neither the cold front nor the warm front can move in the direction that they had been moving until they were stopped, as it were. So put that here so you can see that. That's your stationary front. Warm, wanting to move up, but it can't because it's running into this cold front moving down. Sweeping parallel winds along the front, behind the warm front, warm winds, cold winds sweeping down behind the cold front. There is unsettled weather along a stationary front. It's not as dramatic, as it were, as a cold front by any stretch of the imagination, but it can be unsettled with clouds forming as cold air lifts warmer air along the front, and we can have periods of sustained precipitation along a stationary front. And of course, sustained precipitation because the front is stationary. It is not moving. And so we shouldn't get the impression that a stationary front is not a front with some weather associated with it in the sense of bad weather. So there is some bad weather along the stationary front with periods of sustained precipitation. And as you can see, we have one last front. The last front stems from the development of a zone of low pressure at some point, some place in the United States, you know, is what we're talking about here. So we'd have a center of low pressure designated on a weather map by an L, and sweeping from that L, we could have a cold front, and we would label it with our blue triangles pointing in the direction the front is moving, with air sweeping in towards the low behind this cold front and behind this warm front. So suddenly we would have now two fronts very close to each other. One, in the case of the cold front, moving more rapidly than the warm front. This is because cold fronts tend to have more energy associated with them because of differences in air pressure on either side of the front. So they'll tend to be moving more rapidly. So in this case, we have movement in this direction of the fronts and air sweeping in towards this low. But what happens is that because this cold front is moving faster than the warm front, it catches up with it and it zips it up with it. It zips up with it in such a way as to make this new purple front called an occluded front. Occluded. Did I spell that right? No, it's like this. O-C-C-L-U-D-E-D. No. An occluded front. So the occlusion happens because the cold front zips up, as it were, with the warm front, and suddenly we have half circle, triangle, half circle, triangle, this time in purple. It might be a little glary over there. We'll show you this colored in. This is our occluded front. So, cold front, warm front, occluded front. Oh, I should have done that in purple. Sorry. Occluded front. This is your last major front type that you should be aware of. And again, what's behind the cold front? Typically continental polar air. What's behind the warm front? Typically maritime tropical air. The center of low then becomes an area where the weather is quite bad, and we can often say that we expect bad weather all along all of these fronts. So we expect bad weather along all of these fronts. The worst of it along the cold, leading towards the low, and in the zone of occlusion, where the two fronts have zipped together. That is your occluded front. Characteristics of fronts. They can be anywhere from 200 meters to 200 kilometers wide. They can be up to 5 kilometers, reach 5 kilometers into the troposphere, and they can be as long as 2,000 kilometers. Fronts tend to occur in the mid-latitudes because this is the region of the Earth in the northern or southern hemisphere where tropical air either moves north in the northern hemisphere or south in the southern and meets colder polar air in the northern hemisphere, continental polar coming down, in our case, from Canada. And again, for North America, the fronts that we are worrying about, interested in understanding, are fronts that are forming where maritime tropical from the Gulf of Mexico air masses meet continental polar air masses from central Canada. This is the story of fronts.